Hello everyone. In this video we're going to demonstrate how to configure Source NAT, which is also known as SNAT for short. As you can see on our screen, the topology of our lab consists of the following devices. One web server that resides in the public internet, an edge router, a perimeter firewall, an internal switch, and an internal host residing in our local area network. Without further ado, we will get started by configuring the IP address of the web server. We will give it an IPv4 address of 203.0.113.10. We will copy that address and paste it here and remove the trailing 0, as the .1 IP address will be that of our edge router. We will close the window, name our router edge router, because it represents the first point of entry into our network. We will open up its CLI, type no, enable conft, and we will start by configuring the interface connected to the web server, which is all zeros. So 0/0/0, and we will run IP address 203.0.113.1 with a subnet mask of 255.255.255.0. We will run a no shutdown, and we will also configure its hostname to be edge router. We will run a show IP int brief to make sure that our interface has been configured correctly. And next we will navigate into the second interface of the router, which is 0/0/1. Give an IP address of 192.168.0.1. 255.255.255.252 is going to be the subnet mask, and no shutdown. Excellent. Show IP int brief, and all is good. We will commit our changes to memory, and we will close the window of the router. Next, we will go into the ASA firewall, which we're going to name perimeter firewall. Conft, and the first interface we're going to configure, if I hover over it, it's 1/1. We're going to name it outside. Its security level is automatically set to 0, which is fine, and then we will run IP address 192.168.0.2 with a subnet mask of 255.255.255.252, and we will run a no shut. We will run show int IP brief just to confirm that the first interface of the firewall has been configured correctly. And then we will enter, I believe it is 1/2 interface that is connecting to our LAN, which it is. We're going to name this one inside. Its security level is automatically set to 100, which is what it's supposed to be. And we will run IP address 192.168.1.1 with a subnet mask of /24, so 255.255.255.0. and we will run a no shut. And we are going to commit our changes to memory. Close the window, and last but not least, we will configure the network settings of our internal host. We will give it an IPv4 address of 192.168.1.10, copy it, paste it in the default gateway and remove the trailing 0. Excellent. Fast forward the time. Let's run a few pings to verify connectivity. So our edge router should be able to ping the web server at the address of 203.0.113.10, which works just fine. And it should also be able to ping our perimeter firewall at the 192.168.0.2 address, which is also working. Excellent. Fast forward the time. And now that we have put in place the necessary networking configuration across all of these devices, we need to take care of our routing. The edge router currently doesn't have any knowledge of our LAN. So we need to go back to the CLI of our router, Cont-T, and run iproot. Should be iproot, yes, iproot 192.168.1.0 with a subnet mask of 255.255.255.0, and then we need to supply the IP address of the next hop router, which is this one, 192.168.0.2. So if I now run show IP route, we can see that we have configured a static route that can forward traffic to our internal network from the internet. And then commit our changes to memory. Okay. Also, if I go to the Cisco ASA firewall and run show route, we see that we don't have a gateway of last resort, in other words, a default gateway, which is going to be a problem. And so I will go into configuration mode and run root outside 0.0.0.0 of any subnet mask, and I will provide the IP address of our edge router, which is 192.168.0.1. So if I do show route again, alright, so I need to exit the configuration mode, I guess. So if I run show route, now we can see that we have a gateway of last resort, or a default gateway, which is the IP address of our edge router. I will commit our change to memory, and we should be good to go with the routing of our infrastructure. Now, let's save the changes, fast forward the time a little bit, and let us run a test and see if the internal host of our network, of our LAN, is able to communicate with a web server. I will remove all protocols and enable only ICMP, and then I will initiate some traffic from the PC in my LAN over to the web server. Let's see what happens next. So we can see that our PC is sending the traffic first to the switch, which in turn is forwarding the traffic to the firewall, which blocks it. And the problem is that if we open up the outbound details of our packet, we can see that the source IP address of the packet of the traffic remains the internal IPv4 address of our internal host, which is an IP address that is not routable out to the internet. So what we need to do is to configure NAT, or in this case SNAT, Source NAT, in order for us to be able to masquerade the traffic and change its source to the IP address of our firewall. Okay, so let us do that next. I will close the simulation. Fast forward the time a little bit. Now bear in mind that even though this network between the edge router and the firewall is a private one, we will pretend that this interface is a public one. Okay, so we will go into configuration mode and we will configure Source NAT. We will run object network obj underscore inside subnet, which is the subnet that our internal host resides in, which is 192.168.1.0 with a /24 subnet mask. Press enter and then type NAT, open brackets or parentheses, and type inside, which is the name of the internal interface of our firewall, comma, outside, which is the external interface of the firewall, the one facing the edge router. Next up, we will run dynamic interface and press enter. Commit our changes to memory. Fast forward the time. Delete the previous packets. And let's open up simulation mode again and rerun the same test. So from the PC to the web server. Okay, so we can see that the PC is generating the traffic, which is going through the switch, which in turn is forwarding the traffic to the perimeter firewall, which this time is not blocking it. Instead, it is forwarding it to its default gateway, which is the edge router, and the edge router in turn forwards the traffic to the web server. And the web server is replying with an ICMP reply packet, but unfortunately we see that the packet is being blocked by our firewall. So to fix that, let's delete the traffic, go back into real-time mode and configure an access control list. So I will run access-list outside underscore in extended permit ICMP any echo dash reply, and we will associate this access control list with the outside interface of our perimeter firewall. So we will run access dash group outside underscore in, followed by the in keyword again, interface outside, the one facing the router, and write the changes to memory, close the window, fast forward the time, and now let us run one more test by initiating ICMP traffic from the PC to the web server. Okay, so we can see that the packet is going through the switch, and when it arrives at the firewall, if we open up the outbound PDU details very quickly, we can see that the source IP address of the host has been translated into the IP address of the external interface of our firewall, which is 192.168.0.2. Okay, the traffic is then being forwarded to the edge router, which is arriving at the web server. And the web server is responding back with the traffic going through the router and then through the firewall, which is allowing it this time until it successfully reaches the initiator, which is the PC of our local area network. Thank you very much for watching.